Alright, so we're going to be talking about the exponential properties today. So this is something you guys learned at the tail end of 8th grade. So it's going to be kind of a review for you for this part before we get into the exponential equation. So just going over the exponential properties. So let's go over when you are multiplying numbers that have exponents. So say x to the second times x to the third. What you end up doing is you add the exponents, right? So that would be the same as x2 plus 3, which is the same as x to the 5th power, right? So that's the property when you are adding numbers that have exponents. Okay? When you are dividing, which you aren't going to have to do too much. So say you have x over 3 over x over 2. You would actually subtract, you take the top number minus the bottom number, so that's the same as x to the 3 minus 2, which is the same as x to the 1 power. Okay? Then we have our power of powers. So this is where you would have something like x to the second power being raised to the third power. And when this happens, you just multiply the exponents, right? So that's the same as saying x to the 2 times 3 power, which would be x to the 6th power, right? And that's all that means. And then we got our zero property. So if we have x to the 0 power, or any number to the 0 power, no matter what number that is, if x was a billion, it would still be the same thing. Anything raised to the 0 power is always 1. Okay, no matter what, it's 1. Okay? And then we've got our negative exponents. So if we had x to the negative 2 power, this is where we get our old man scenario. If you guys remember from last year, he's got that downstairs neighbor, and this old man, he's got bad knees, so they're living in an apartment. Old man's on the 2nd floor, has to climb the stairs, so he has bad knees, so every time he climbs the stairs it gives him this negative attitude. So he agrees to switch with his downstairs neighbor, and they go downstairs, and his attitude becomes positive, and it becomes 1 over x squared. So basically, whenever you see a negative exponent, all it's saying is that is a fraction, and if you move him down to the denominator of a fraction, he becomes positive. Okay? If there's not already a number upstairs, like if this was like 5x to the negative 2, then 1 would just be there. But if 5 was up there, then the roommate would stay, and it'd be like 5 over x to the 2nd power. But any negative exponent just means that number that has a negative exponent is going to go downstairs, and that exponent is going to become positive when that happens. Okay? So let's go through and simplify some of these, just to remind you guys how this works. So 3 to the negative 1 times 3 to the third. Okay, they have the same base. So all we have to do is, when we multiply, is we add our exponents, right? So 3 plus a negative, or negative 1 plus 3 is going to be 2. So that gives me 3 squared, which is the same as 3 times 3, which is 9, right? Okay, let's look at another example. So let's say I have 3 to the second times 3 to the negative 4. So 2 plus negative 4 is negative 2, right? 3 to the negative 2 power, he's going to go downstairs, become 1 over 3 squared, which is the same as 1 over 9. Okay, not too tough, right? What about right here? We have 2 to the, if there's no exponent, that's the same as a 1, right? So we have 1 plus 0, so that would be the same as 1, so 2 to the 1 power would just be 2 to the 1 power, or 2, right? And that'd be my answer there. Let's see, another one I want to do. Let's come down here and do one of these more complicated ones. So let's say I have this big bunch of terms here. I'll zoom in a little bit so you guys can see. Got this big bunch of terms here. So again, our exponent rules, we can only use them when we have the same base. So what I'm going to do is I'm going to go through these just a base at a time. So the 3 and the 2 out front here don't have any exponents, so just normal multiplying rules would apply. 3 times 2 is 6, right? So our constant in front is going to be 6. Then I'm going to look at my a's, and I'm going to count up my exponents, and since they're multiplying, I'm going to add the exponents together. So I have 2 plus 2 plus 4. So 2 plus 2 plus 4 is 8, right? So that'd be a to the 8th power. Okay, then I'm going to look at my b's. So I have -1, 3, and 3. So -1 plus 3 is 2, plus 3 is 5. So it'd be b to the 5th power. And that's as simplified as I can get it, so that's my answer right there. That's all I got to do. Okay, let's look at one of these powers. So down here, I've got multiple terms inside my powers. So again, we would multiply those numbers with their exponents, right? So the 2 outside would multiply with that 2 over the n, that 4 over the m. Is there a number over that 2? There isn't, but if there's no number, there's an implied 1 there, right? I've got to multiply that 2 by that 1 as well. So that would give me 2 squared. 4 times 2 is 8, so m to the 8th. And then 2 times 2 is 4, n to the 4th. And the only thing else I can do to actually simplify this more is to actually do 2 to the 2nd power, which would be 4. So the answer would be 4 m to the 8th, n to the 4th. Not too tough. Do one more example, just a quick one. -3 and 0, so I'm going to times that -3 by 0. -3 times 0 is 0, so that gives me 4 to the 0 power. Any number raised to 0 is always going to be 1. So that would be my answer there. Okay, so those are the exponential properties.